Thank you, Jack, and thanks everybody at Michigan State for the invitation. Hopefully you can now see my shared screen with some slides here, and there we go. So I wanted to talk to you today about in the spirit of Rachel Carson and the School of Sustainability, about work that we've been doing with many colleagues here at Duke, but also other colleagues around the world to really try to encourage sustainable behavior and to inform policymakers about the benefits of climate change mitigation. And what that does for really things that tend to be important to people, that people can really relate to, which are things like health and the economy. Often with something like climate change, we show graphs like this. This is probably the most iconic type of figure there is, which is essentially it's global warming. What I have here on the left is from the European Union's data set on global mean annual average temperature change. And of course, when you look back at the um, period just after industrialization at the end of the 19th century, if you use that as zero, then we began warming rapidly in the 20th century, and especially post 1970 or so, we have this climb up to running mean that's well over 1.2. And on the right, they've included every single year up through last year since the 70s. And you can see that, in fact, last year was pretty darn close to 1.5. Now, what we do in the science community is we often tell people about how important it is to avoid things like a warming of 1.5. And part of the reason I'm showing this is to be, clear-eyed about how effective that's been. First testimonies in the 80s, IPCC reports started in the 1990s. And what the temperature graph on the right shows is that essentially the warming has just continued. You'd see a similar kind of thing with the CO2 levels in the atmosphere. We've been talking a lot about change, and we haven't managed it yet. And it's not only because the scientific community speaks about global warming. We do a lot more than that. Here's an example of a paper that a postdoc of mine led back 15 years ago. And what she showed was that we would expect these impacts from something like continued global warming, which would be a dramatic increase in fire. And if you look at the lower right, you can see that map there. If we look at the United States, right, the eastern part of the country would see fewer fires, but we projected the West would see many more fires, and up into Canada as well, increase in fires, and in fact, many other parts of the world. One of the things that's most disappointing about a paper like this is when you look back 15 years later, you would think that it might be nice to say, hey, we were kind of right in our predictions. But really what I feel is that what was the point of making these predictions if we said the West would catch on fire all the time if we don't do something, and we went ahead and didn't do anything, right? So unfortunately, we don't want to make predictions about the impacts of climate change and then wait and see that they come true. What we'd like to do is change the trajectory by providing this kind of information. But clearly, when we show global mean temperatures, we even show increase in fires at the regional scale, it's not and has not been as compelling enough to get major change. And I would assert to you that one of the key reasons for that is revealed in an analysis like this, which came out in a paper 2 years ago, which is the profit from the oil and gas industry alone has been delivering about 1 trillion per year on average over the last 4 to 5 decades. If you think about 1 trillion a year, that's essentially pretty close to $3 billion a day. So when we say climate change is going to be an extra 1/10 of a degree in another 5 years if you don't do something, and there'll be more fires, that has to be compared with the intense motivation to delay phasing out fossil fuels because of this profit that you get of $3 billion every single day. So can we really provide information that's as compelling as continuing business as usual and reaping this $3 billion a day? Well, people have looked into these things, and of course, I'm not the first one to raise this question. An example is the Stern Review that the British government commissioned and looked at impacts of climate change, the economic impacts. And here's a slightly more recent version from the OECD from 2015, a report called The Economic Consequences of Climate Change. And what it showed was that all around the world, the net economic consequences were damaging, right? And so the idea here is that while you may get increased crop yields in a few places like warming of Canada and northern parts of Russia, right, overall everywhere around the planet would suffer damages. There are no places that really come out ahead. And the message that often comes from this is something like doing nothing will actually cost more than acting, because the damages for climate will really grow over time. The Stern Review that I mentioned before had the same conclusion. And this is true. Doing nothing will cost more than acting. But one of the things that's missing from this is, the report that I'm drawing from here on the right looked at the impact of policies enacted in 2010. And if I look at 30 years later, and I look at the wealthy parts of the world, what I find is that 30 years after taking action, I've just barely started to see a reduction in damages related to climate change. So while doing nothing will cost more than acting, doing something requires reducing that $3 billion a day in profit now for the sake of avoided damages decades down the line. And global average is slightly larger, but it's really still this trade-off between immediate benefits and long-term damages, which are often beyond the time that the current decision makers in either government or industry will be still in that role. It actually can be even more tangible, and I want to show you one little example, which I hope will work over the internet here, over the Zoom. And when the fossil fuel industry in particular would like to influence policy, they get even more specific about the economic consequences and don't just look at the impact on their bottom line, but they really are able to bring this to individuals. Here's an example.
The president must decide if he'll sign a UN climate treaty that could increase the cost of gasoline by 50 cents a gallon and raise electricity and natural gas prices by 25 to 50%.
So you can see, I mean, it's kind of funny to see this. The gas prices were $1.20 something a gallon. But the idea that they would go up 50 cents a gallon is a huge jump when you're starting from $1.20. And they show somebody's utility bill here going through the roof, right? And so the idea is that if we take action, there are these immediate costs that can be relayed tangibly to individuals. And this is an ad, in fact, that was released when the United States was considering whether to sign on to the Kyoto Protocol. And as probably everybody knows, this kind of lobbying effort was very successful, and the US did not sign on to the Kyoto Protocol back in the 1990s. So these kind of arguments work. They have been used very effectively in the past. And when you convince individuals that turning to sustainable development will raise their utility bill and their gas prices, and you don't show that there are actually any benefits of this, then people don't want to take action. So what we've been trying to do, that's kind of by way of background, what we've been trying to do in my group is to do our best to quantify some of the benefits so that we can say it's not only a change in your utility bill and your gas prices at the pump that you should be thinking about, but there are other things you should be thinking about too, which might be quite compelling and convince you that taking action was maybe not the not going to wreck the economy the way you might have been told by others. So what I'm going to spend most of the rest of this presentation on is looking at some of these benefits. We've looked at human health because that tends to be important to nearly everybody. We've also looked at labor productivity and how that might change, which is very dependent on the individual sector of the economy you're talking about. I'll talk very briefly about impacts on agriculture and crops, and then the economic valuation of all these things is important too, to kind of contrast this message coming out from analyses looking only at costs and ignoring benefits. And one of the real innovations in this, I would say, with respect to much of what's out there, is that we want to look at any pathway that affects health, productivity, agriculture, the economy, etc. And in particular, we want to look at both climate changes and air pollution, as well as other things. And the reason for that is that fossil fuels are the same source that is driving both of these, climate change and decreased air quality. It's obviously not the only thing. Wildfires and deforestation, other actions are important too, agriculture. But here I'm going to concentrate on fossil fuels, which are the dominant source of both of these. And really our goal could be expressed as making this chronic diffuse problems like statistical differences in deaths from air quality more tangible to people. So I'm gonna talk in two parts here. The first is going to be about decarbonization, and I'm going to begin showing some results from a paper that came out in 2021, where we tried to really look at how these vary in space and how they vary in time. And this paper is focused on the United States. A lot of Duke students and postdocs and such are involved in this research. So here's an example of one of the things that we found, which is looking at the impacts of particulate matter. And this is looking at small, fine particulate matter that affects human health. And what we see here is on the left, a map of how many fewer deaths there are associated with exposure to fine particulate matter under a scenario that's focused on sustainable development and consistent with getting us back under 1.5 degrees by the end of the century versus a reference case. And so obviously there's some influence, a strong influence in this of population. States like California, New York, and Texas have a lot of people, but it's not only population here. What's going on is that we can also see that the Ohio River Valley going from Illinois up through Ohio, Michigan, and to the mid-Atlantic states is a hotspot of particulate matter exposure, because that's still where we have a lot of our industry and especially our coal-fired power plants. And the more quickly we get rid of them is obviously good for climate change, because coal is the most CO2 intensive fuel, but it's also the dirtiest fuel for air pollution. And so both from sort of Illinois and downwind of that off towards the Northeast, you're going to see large benefits. One thing that we have then, on the wrong button here, there we go. We have computed different types of health benefits, and we find that in the 2030s, what we see is on this map here, that fine particulate matter is the largest benefit, reductions in fine particulate matter, that is, if you have a low emission scenario, are the largest benefit in most of the country, but not all of it. And you have places like Florida and a couple other states in the Southeast, as well as most of the mountain states where ozone is a more important benefit for reduced climate change and reduced emissions. What you see is in 2030, and our scenarios are looking at policies starting to be implemented in the 2020 range. You don't see heat being the most important anywhere, and that's because climate is slow, right? When you reduce emissions, you can affect air quality very, very quickly. but you do not affect climate very quickly. It takes quite a while. And so if I move here to 2070 on the right, you can see that fine particulate matter still is the most important throughout most of the country. But now heat has become the most important public health benefit, reduced heat exposure, across much of the Mountain West, but also up through states like Washington State. And you might remember that there was this massive heat wave that affected Oregon, Washington, and even up into British Columbia in the summer a couple of years ago that really killed a lot of people. It was a heat wave that's kind of similar magnitude to what we get as far as absolute temperature down in the southeast where I live routinely. But people are really more susceptible in places where that has not been typical in the past. So you see heat becoming important really in the northern states, Maine, up through across the northern part of the country. And it's important as well in places like New York and Michigan and such, but they have so much more air pollution that it doesn't quite surpass PM as being the leading impact. So to make these kind of things more tangible to people, since we have lots and lots of state level results, one of the things that we've been working on is trying to make interactive web interfaces, not quite professionally designed, I apologize for that, but hopefully still vaguely user-friendly. And the user can then go through, and here I'm going to show you, there's a menu of scenarios. You can look at the year you want. And there's all kinds of impacts in here, health impacts, morbidity impacts, agriculture, etc. You can look, for example, I put the cursor over California and then California again, ozone deaths on the left, PM on the right. They're about similar. But when I look at Florida, ozone is much more important. When I switch to a state like New York with less sunlight, less photochemistry, ozone less important and PM more important. If I then try to compare with something like what I showed before, which was deaths due to heat exposure, right? I can see that the pattern becomes different still from what you get from air quality, with now California being much less susceptible to heat than to ozone, but a state up north like Minnesota, the value there for ozone 320 and more than double that for heat. So depending on where you are in the country, what's more important changes. Now, if I switch here to work loss days, so labor productivity, I've got air pollution on the left, and I'm going to put heat exposure on the right. Right? You can see that they're very different patterns now. For air pollution, it largely looks like the health impacts of air pollution. So it's big in states with a lot of pollution, but heat tends to not be important at all for labor productivity in a place like New York. If I now compare Texas, right, heat is far more important. And so unlike public health, where people dying from heat exposure, it's much more sensitive up north where people are not used to heat. If you're out working on a construction site or in a field picking crops, like heat is really can be really damaging, and it's not, you cannot adapt the same way you can by going to, say, a cooling center, because you have to keep working. So the labor actions, the labor impacts of heat tend to be predominant in the south, where the health impacts of heat tend to be predominant in the north. And so you get different patterns depending on what impact you're looking at. I want to kind of close out this part about the United States by saying that when we made this public data set, one of the groups that used that was the House of Congress, the House of Representatives, that is. And in 2020, when we released this web page, this web-based data set, congressional reports were released for a whole bunch of states by some of the congressional committees. And I think one thing that the reason I'm showing some of these newspaper headlines is that it can be really compelling for people to not think of climate change and air quality as this diffuse problem, but have data for the place that they live. And so here's a headline from California, picked up by a San Francisco newspaper because this congressional committee released a report based on that data for the state of California. Here's one for the state of New York. one for the state of Florida. And you can really start to, instead of have this diffuse problem that we need to mitigate climate change because of, the whole planet, you can instead say, we really need to adopt sustainable development because of my state, where I live. And here's the last thing from the paper that I think is interesting is I've plotted here the benefit cost ratio, looking at the implementation cost for sustainable development trajectories in the United States and comparing with just the health benefits from reduced heat and air pollution exposure. And you can see that red line and range down there is echoing the reports that we've seen in the economic literature for a long time, that eventually the impacts of climate, the damages from climate change are larger than the mitigation cost. And so as the conclusion I presented before from, say, the Stern Review shows, the cost of doing something is less than the cost of not doing something. And that is, again, true, but you can see that it only really becomes true here in the 2050s and thereafter. But if you look at the blue, which is the air pollution effects, you can see that the benefits outweigh the costs in the very first decade you take action. And so that's really one of the benefits of this approach of including health impacts that are not just related to climate change, but also related to air pollution, is you can see that the timing of the air pollution benefits is much more rapid than the timing of climate-related benefits. To summarize what we found in that paper, I'd say we found that the benefits I didn't really show them, but for crops as well as labor and health are primarily from air pollution in the next 40 years or so. But eventually, the effects from climate, which is primarily heat here, but also things like rainfall changes for crops, these grow larger and they often dominate in the second half of the century. So both are important and both are worth trying to realize these benefits by adopting sustainable development policies, but they occur on quite different timescales. We wanted to then, having had a positive reception, for example, the Congressional Committee's use of our results, we wanted to see if this would be true elsewhere. So we have most recently extended this to several countries in Asia, using results from a large variety of climate and air pollution simulations by teams around the world. I won't go into details too much, but it's all in this paper that just came out earlier this year, 2024. And what we found there is, for example, I'm showing here results for China as well as the US. And the solid line and its range is a sustainable development 1.5 degree scenario, where the dashed and its range is kind of a reference case. And so you can see in somewhere like China, right, a similar story to the United States, in that you get large reductions in particulate matter exposure, so air pollution exposure to citizens very quickly when you take action on sustainable development. What we didn't know was how important these would be relative to climate benefits and how large the benefits would be relative to mitigation costs until we did this. Because what you can see is that China is starting from a very different level in the vicinity of 75 micrograms per cubic meter of particulate matter, where the US is more like 7.5, right? So with 10 times as much air pollution, maybe you'd get a different story. And we looked at South Asia as well. And I'm going to now show a slightly more complicated slide than is perhaps ideal, but I'm going to try to just focus on the key bits here, which is in the top row, I have a 1.5 degree scenario, and in the bottom row, I have a reference case. And I want you to just really pay attention here to the red bar, which is exposure to environmental change. And if I look at the upper left panel and I look at, say, China, this black dot is the sum of all of these bars. But you can see this red bar is that I've dramatically lowered the exposure of humans to particulate matter when they breathe in the ambient air outside. And that has reduced losses by a couple million people per year than what would have happened otherwise. If I go down to the case below it, and I again look at China, in the reference case, I have close to 2 million additional deaths relative to the present every year. What's interesting is that part of this is the orange bar, which is this population is getting older. And the population is getting even, in the upper one, even older, which is kind of a counterintuitive response, but it makes a little bit of sense as what's going on is with more sustainable development, people are healthier and people live longer. And given that, they have more chance to die from air pollution, kind of slightly unexpected impact there. So the reduction in particulate matter might not lead to a net reduction in total number of deaths. So this red bar is smaller than the orange one, but it greatly offsets what you'd see otherwise, which would have been a large rise in deaths. And we have similar conclusions for, I've got India here, Bangladesh, and Pakistan. The United States is there as well, but harder to see. And then on the right, it's similar, but it just moves to the end of the century. The last thing I wanted to show about this is if I add in the end of the century for heat, right, what I see is that the red bars go up in both cases, right? The upper case is the 1.5 C and the bottom is the reference. So unlike the case of particulate matter, where adopting sustainable development actually gives us a decrease in deaths associated with exposure to air pollution, we can't turn this into a decrease. The planet still gets warmer even with sustainable development, but it does not get warm as nearly as much as it does in a reference case. Right? So the red bars point in the same direction. More people die from heat in the future in all countries under both scenarios, but far fewer die from increased heat exposure under a sustainable development scenario, this upper one, than under the lower one. The other thing is that the uncertainty range, which is this black line around the dot, is much larger for climate change than it is for particulate matter. And that's really in part because people die from heat exposure even in as little as 1 day of extreme heat, whereas particulate matter is, we're looking at much more the effects of chronic exposure rather than short-term, whereas heat is both short and long-term. So to summarize what we found here for the extension to Asia, when we put a monetized value on the health-related benefits in a place like China, we get a similar conclusion to what we saw in the United States, namely that the health benefits much more than offset the cost to a transition to a net zero emissions. And in India, they offset at least a large fraction and perhaps more than the total cost of the transition as well. They don't catch up to the impacts of air pollution ever in the century the way they did in the United States. They don't become more important, but that's primarily not because the impacts of reduced climate change are not as large, but rather that the impacts of current air pollution levels are much higher in South Asia and in China because their air is not as clean as ours is in the United States. Nevertheless, the conclusion from all three regions, South Asia, the United States, and China, is that the health benefits of air quality that are realized rapidly in the near term often outweigh the cost of the transition to a sustainable economy. However, this also complements results that we have been working with Chinese colleagues for a long time to point out that since China really does value clean air, that this is linked to its sustainable development goals and to reducing its CO2 emissions as part of climate change. So this is coming at the same question from another direction. Can you reach your air quality goals without decarbonization? The answer being probably not in a place like China. So the conclusion from all this is that unfortunately, climate action yields little in the near term from avoided climate change itself. It takes a long time for the climate to respond to your policies, So eventually you'll get a lot of benefits, but they won't be quick. Whereas at least some industries, right? Remember that $3 billion in income a day, right? Some industries will start to lose that income. It will go to other industries, but there will be winners and losers. And these environmental health impacts will increase as the population ages. Deaths from other causes are reduced, so we have to keep that in mind when looking at results for future health projections. The good part about all of these conclusions is that most of our benefits come quickly, and that's what people tend to prioritize. They're larger than many prior analysis because our understanding of just how damaging air pollution and heat are to human health has improved. Most of them are from our own action, right? Because air pollution is not strictly a local problem. It's not as if one town can change its air quality completely, right? If stuff is blowing in from upwind sources. But for example, when we look at the entire world acting versus only the United States acting, about 2/3 of our air quality improvements are a function of our own domestic actions. That's quite different from climate, where climate benefit really requires worldwide action. And most of these benefits are related to things like health and economics and can be quantified. So I want to switch gears slightly for the next few minutes before I end here and talk about one additional area, which is related to this first bad item listed there, right? Climate action yields little in the near term from avoided climate change itself. Now, why is that true? There's both inertia in the climate system, but also what we're doing is we're decarbonizing when we phase out fossil fuels. And carbon CO2 in the atmosphere takes a long time to respond to changes. And CO2 is emitted from things like those coal-fired power plants that I mentioned in the Ohio River Valley and coal plants around the world, right, is emitted along with aerosols. And phasing out the use of coal reduces these aerosols, which actually mask greenhouse gas-induced warming at the same time as you reduce CO2. So it's just really, really hard to get near-term benefits for climate by focusing on decarbonization alone. So the other topic I wanted to mention is focusing on methane as a separate and complementary level to decarbonization, to decarbonization, to try to get us some benefits for climate in the near term that will bring forward some of the timescales for reducing things like heat exposure and the health and labor impacts that go with that. It's not a substitute for decarbonization. We still need to do that as CO2 is the dominant driver of climate change. But methane is number two, and it's much shorter lived and so can provide us benefits in the near term. What has to happen for us to really get to a 1.5 degree consistent pathway is for methane, which has more than doubled since pre-industrial, to really start dropping very, very quickly. And so we produced an assessment designed to show how this could be possible, and in the same spirit as the rest of this presentation, to show what the benefits of that would be. How it would be possible is really reducing very quickly emissions from the fossil fuel sector as the easiest in both a financial and technical sense to reduce, but also taking a smaller bite, but still substantial bite out of emissions from the waste and agriculture sectors. And one thing that we were at pains to point out is that while decarbonization would eventually get rid of a fair amount of the fossil fuel related methane emissions, it would be slow and would only get you about 1/3 of what targeted actions focused on methane itself would get you by the middle of the century. One other thing to keep in mind when we think about the impacts of methane is one of the precursors to ozone at the ground. And ozone is bad for ozone is pretty toxic, right? Highly reactive. It's reactive for people. When we breathe it in, it causes deaths, as I've shown before, as well as morbidity outcomes. It's also bad for plants. And so if you compare something like CO2, which is going to make the planet hotter and cause droughts, at least in some places, some of those climate-related damages are offset by the effect of CO2 fertilization on plants. With methane, not only do you not get fertilization, but you get additional damages from ozone. And some of the prior work that we've done had shown that in high versus low emission scenarios, you could actually get a much larger impact of methane changes than you would of CO2. And this is the kind of thing with the ozone effect is easy to show in, for example, here's 3 pots of growing wheat with filtered air on the left, and on the right, the ambient air from Pakistan, which has very high ozone levels. So this is not, rocket science or something. This is just something where we know that ozone has these effects. We don't know it for all species of plants around the world, but we do know it for many of the main crops. And so we quantified, again, the idea of quantifying benefits from taking action. You have the climate benefit, which is a few tenths of a degree of warming shaved off, which is quite appealing given that it's so hard to make a dent in climate change via decarbonization in the short term. But in addition to that, there are reductions in deaths from ozone exposure. There are reductions in crop losses due to both ozone and avoided climate change. There are work hours. There are asthma-related hospital visits, et cetera. And we also showed that much of this could be done relatively inexpensively because there are actually many methane control measures that pay for themselves. Others are low cost. And then some are more expensive, but a relatively small portion of the total. Then there are additional things which are really much more related to behavior, like getting organic materials out of the waste stream, right? So essentially throwing your food scraps into compost and sending them off to compost collection rather than into landfills, and eating less beef and dairy so that we have fewer cows. Those are not cost-sensitive measures, but are behavioral. When I talk about costs here, it's also important to point out that I'm neglecting environmental damages. Virtually all of these would pay for themselves if I included the effect of climate change and air pollution. But what I'm just looking at is the effect of the cost paid for somebody, say, fixing a gas leak in a pipeline, right? That can have a negative cost. And we've seen that much more recently with the advent of infrared cameras. This is extracted from the New York Times, where they were looking at a storage tank here, and it says, do you see the methane leak billowing from this tank? And no, of course, we can't see it in the visible, but here they photograph it in the infrared, and you can see that there are things like this, a storage tank for natural gas that's just pouring off loads and loads of methane. So fixing a leak like this can pay for itself because obviously nobody's deliberately leaking from a storage tank. This is an accident. The cost estimated by the IEA for the energy sector to cut methane emissions by 75% is about $75 billion. That would be offset by about 45 billion in revenue. So really not such a bad deal. There's still resistance because, you're spending $30 billion in total. But if you think about that, that would be about 2% of just last year's profits. So it's really not a giant ask to get industry to control its methane release from oil and gas. So again, we made one more of these websites where you can go through and you can look at available control measures. And see if I can press play here. You can go through and it will show you the benefits in terms of avoided climate change and avoided ozone and such in each part of the world. But again, that's hard for people to relate to. So we can also show things like avoided impacts of number of people dying from ozone exposure. In India is the largest in the world, but China and the US are substantial too. On the right, it's per capita, so you can see what regions are most sensitive. And here I mentioned agriculture. For example, you can look at the change in wheat yields or rice or corn or soy. Here I have labor productivity. So again, a country like Brazil might be much more interested in labor productivity changes than anything else. And down here, we have the last bit to show you is, well, sorry, I meant to stop right there. The last bit to show you, which will come back to it in a second, is the cost, right? And we can see that up here in the right is the amount of methane that can be mitigated. And when you get down to the next section here, it shows the cost for each measure, and it shows the benefit for each measure that's available. And so what you can see is once it gets to the right section, apologize, I pressed the wrong button there. You can see that often the benefits that you obtain by putting in place these different emission controls substantially outweigh the costs. There it is. These cost on average $162 a ton, and the benefits that are received are $4,300 a ton. So this kind of stuff was used by the European Union and the United States. This is part of the letter that they used to invite other countries to join them in the global methane pledge. And one of the nice things about that was you can see that I've circled here, the recent global methane assessment showed that they have the potential, these measures, to avoid over 0.2 of a degree of warming by 2050, while yielding important co-benefits, including improved health and agricultural productivity. So this idea of quantifying the benefits, I feel, is quite helpful. We have another data set to support implementation of the pledge, where you can go and look at all of the different options and select the country you want, select how much methane you would like to get out of the atmosphere, or how much emissions you would like to reduce, and then it will show you what the best measures are that are available. Here I've selected Algeria and I've selected the oil and gas sector, and it will show you what you can do. It will also show you how much each individual one costs, how much it mitigates, and it will compare for you energy sector versus waste versus agriculture, so you can ensure that you're focusing on the area that might be most effective. Turns out here in Algeria, you actually have larger mitigation potential, or less expensive mitigation in waste sector than you do in energy sector, which is kind of interesting. And when I turn to, for example, Pakistan, I find even larger mitigation potential in the waste sector. We also give the availability of mitigation, not just the cost and the amount, but the percent that we think is available. And it might be 24% of Pakistani emissions from landfills. The reason that's important is because as we get new satellite data, for example, here, this is looking at the landfill outside the city of Lahore, and using a global satellite on the left to find that there's a large plume there, and then using a local satellite to home in on that site and quantify the magnitude of the plume on the right, we can see that probably the Pakistani waste sector emissions were dramatically underestimated once we have a new value. So we can apply that 25% potential reduction to the much larger starting point. These are important too, these methane emission reductions, because it's not only accidents like storage tanks, but for example, when you drill for oil, often you find natural gas, nearly always, and sometimes the companies really don't bother to put in place equipment to capture and utilize that gas. And here's really the most stark example I can think of, an oil field in Nigeria, which was owned by some of the big major companies, Shell, Total, and the Italian company Eni. Had very little flaring. They pumped oil out of it and they captured and used the gas. When they sold it to a private equity-backed firm in 2021, the volume of gas flared mushroomed. And so the demonstration here is that it's not a technological challenge, right? Because the gas was being captured and used at this field. And it was being done because companies like Shell and Total have a consumer-facing profile, and consumers can get mad at them, and shareholders can complain, and people can stop going to fill up their cars, for example, at a Shell station. So they have an incentive to behave well, whereas a private equity firm can do whatever the heck they want, and they feel like they can make more money just letting rid of this gas, just burning it off and pumping ever more oil. So in some cases, the release of methane is deliberate, and we really need regulations to go into place, even for something that ostensibly might pay for itself. And what we tried here is to really show how measures that pay for themselves don't always get taken. The green shows the value of methane abatement, and when gas and oil prices are low, it might cost you, say, minus $20 per ton or per barrel, depending on, I'm comparing oil versus methane capture. As prices get higher, the methane abatement measures all pay for themselves, but the value of pumping more oil gets you even more income. So the IEA had a press release last year, and it said methane emissions remain stubbornly high, even as soaring energy prices make action to reduce them cheaper than ever. Right? Well, that's true, but action to do other things or other actions with the same amount of money are even more profitable. And so the fact that methane controls often pay for themselves is not enough. We need things like in the United States, we now have a fee on methane. And so the Global Methane Pledge has extended to 150 countries. We have more than 50 action plans. There's a lot of work, but few have direct costs. And so we still have a ways to go on methane. We can quantify the benefits. We can show where interventions are most successful, but it's challenging to get people to do that. I want to close by just summarizing the two parts. Decarbonization provides health, crop, economic benefits quickly. It provides benefits from our national actions. And alongside decarbonization, we have additional leverage for things like controlling methane. We're trying to work with the Chinese government as well, which is the world's largest methane emitter. Hopefully they will take action as well as all of the pledge countries. But regulations really are necessary, including explicit valuation of the environmental benefits you get from reducing methane. That's really needed to reach goals. I want to stop there, and I'm happy to answer questions. And so I'm going to end there and see if I can find the chat with questions. Yes, I see some questions. Super. Okay. Let me look here. Agree that including pollution health benefits of climate policies matters a lot, but we need to take this forward to embed it in goals. And universities have been motivated to adopt in 2018 a goal of fossil fuel neutral free rather than carbon neutral free, because we brought it to realize the massive additional air pollution benefits of efforts to mitigate climate change via energy policies. Too many places still frame goals as carbon-free or neutral and let fossil fuels off the hook. Yeah, that's a great point. Thanks to William Clark, put this in the chat. I would totally agree with that. I think that by being carbon-free is often done in a way that is not maximizing societal benefits, right? If you still run a fossil fuel-fired power plant, but you plant some trees to offset the carbon, you're not offsetting, say, the sulfur and nitrogen and other air pollutants, the particulate matter, the ozone-forming compounds that come out of, say, a coal-fired power plant. So it is not equivalent, even if the carbon has been canceled, the air pollutants have not been canceled. And that's one of the problems with trying to say have a cap and trade system that only values CO2, right? You would really want to value all of the other pollutants as well. There's a second question in the chat, which says efforts to make benefits less diffuse, focus on geography. Have we considered other dimensions of granularity that might make the benefits feel real? For example, by age, cohort or by sector you work in or others? Could it be worthwhile to explore other dimensions of granularity and think of how we would measure the relative effectiveness in each in moving knowledge into action? So thanks for that question. I would say that's again, that's a two-part question. The first is, have we looked at other dimensions of granularity? And the answer there is yes. We have looked at how different ages are affected, and there's a long tradition in the medical field of trying to figure out what's the most useful thing to look at. And I would say that most of the people who work in epidemiology and analysis of public health impacts don't use total number of deaths anymore, but use more sophisticated things like disability adjusted life years, years of life lost, et cetera. And that's precisely because, as the question's pointing out, right, it's not the same to have a premature death of somebody who's already in their 80s versus somebody who's, in their 20s, for example. So the reason we use total deaths most frequently is because the economic literature is most well developed to put a price on those, which can then be used in these cost benefit comparisons. But we do look at other things, and you're right, what becomes challenging is kind of your second message. How do we measure what's most important? And I think that the answer is unfortunately quite complex, that it's not always clear. One of the reasons we put all of our data sets online is because different people might be interested in quite different things. And we are able to have people look at whatever they find most compelling. And so I was in a meeting, for example, one time, and a government minister from a European country came up to me and said, we're having a crisis right now in that we don't have enough hospital beds for patients. So can you tell me how many hospitalizations are avoided? Really, it's, I work in this division of the government that's in charge of running the hospitals. And to be frank, if more people die, that doesn't cause me problems. But if more people go to the hospital, that causes me major problems. And so, what's going to be important to a particular policymaker is, I think is what you're getting at. And I think that's a really diverse set of things. So, some people, it might be the agricultural yield. Some people, it might be how many school days are lost for children, because that can affect the economy too. It's not just children and their learning, but a caregiver typically has to stay home too from work. And so all of these things, I think, are going to have different constituencies. The next question I see here in the chat is a complementary strategy of energy efficiency and demand management. And yes, thank you, Janice. I would completely agree with you. That is typically included in the decarbonization scenarios where we draw from the model runs done to support IPCC. So they include lots and lots of different things, and it's hard to separate out what's what there. But you're completely right. With energy efficiency, it's often a bit like some of the methane measures I showed at the end, where it pays for itself. And the challenge is getting people to deal with the upfront costs of, say, buying a more efficient air conditioner, even if it pays for itself over the lifetime of the air conditioner. People often don't want to do that. And so encouraging, either with financial support, people to take efficiency measures, or mandating, standards for appliances, things like that. But when you get to demand management, I think that really is a key. And one of the things I didn't really have time to get into too much for methane was that agriculture is currently about equal to fossil fuels in terms of the total emissions from that sector. But in future scenarios, if we are successful in reducing fossil fuel emissions, we still have agriculture quickly becomes the largest sector, and we don't have the same ability to reduce emissions while keeping everything else fine, right? From the oil and gas, for example, you can stop flaring and leaking gas, and we know how to do that. We can inspect pipelines. We can change our equipment and replace seals in pumps, things like that. We don't know how to still have the same amount of livestock we have now and have them not burp up as much methane. So there is a real key role for thinking about demand in those cases.
Yeah, thank you so very much, Professor Shindell. We may have more questions, but we run out of time, and really appreciate your outstanding, terrific lecture and answers to those questions. And also, I want to thank the audience for participating in the lectures. And we have to say goodbye now, everyone. And thank you so much for your great participation and time. So thank you.
And thank you again, Jack, for having me.
Yeah. Yeah.